So this video here is going to be looking at tangents and chords. So I'm going to go through 3 questions. I'm just going to do a quick recap on tangents and chords. So remember, we'll have our circle. We'll have our circle. The chord is the line that's cutting through one point to the other side of the circle, but it doesn't go through the middle because that'll be a diameter. And the tangent is the line that's touching the circle at a perpendicular. Yeah, so it's a circle at a right angle from the radius. So if you had a radius, boom, it's touching at the tangent at a right angle, so it's perpendicular, so the gradient will be perpendicular. And a perpendicular bisector of the chord would mean is cutting the chord through the middle. Yeah, so just a quick recap on circles and tangents and chords. So now, starting with our questions. Sometimes it's helpful also to draw the question as well, wherever they say to draw it out, if it helps you. Just forgot this out. Alright, so let's start. So the line x plus 3y minus 11, it touches the circle at 2, 3. Find the radius of the circle. So to find the radius for this question, simply I'm just going to substitute my xy coordinates into the equation of the circle to find the r squared. So we have 2 plus 1 squared, add 3 plus 6 squared equals r squared. That gives us 9 plus 81, which equals r squared. Therefore, r squared equals square root equals 90. So equals 90. So r equals square root 90. Yeah, which equals 3 square root 10. Cool. So the next part, it says show that the radius at 2 feet is perpendicular to the line. So we've given this line here. We're going to show that our radius of our circle. So if I'm just going to draw a quick sketch. So we had a circle. Let's say the line is going up like this, but it's touching the circle. The radius here is perpendicular to the line. So to show that it's perpendicular, it's going to have negative. So the radius, the perpendicular gradients can be minus 1 over m. Yeah, perpendicular gradients can be 1 over m. So let's find the gradient of the line by rearranging. So if I just rearrange that line, y equals 11 minus x over 3 plus 11 over 3. So the gradient here for the line is minus 1 over 3. So now I want to show that the gradient of the radius is positive 3. So this is question B, this is question A. So to show that the radius of the gradient of the radius, we're going to use our coordinates. So we have coordinates 2, 3, and we'll have the coordinates. We'll get the coordinates of the center of the circle, which is, we looked at previously, minus 1 and minus 6. So using our y2 minus y1 over x2 minus x1, that will give us y2 minus y1, so 3 minus minus 6 over 2 minus minus 1, which equals 9 over 3, which equals 3. Yeah, So we could just show that 3 times minus a third equals minus 1, which shows that it is perpendicular. Okay, question 2. It says the point P1 lies on a circle of center 4 to 6. Find the equation of a circle. So let me just quickly draw it just to make it a bit clearer. So we have a circle, that's the center 4, 6. It touches a point P1 minus 2. Yeah. So they're saying find the equation of a circle. So the equation of a circle is x minus a squared plus b minus c squared, so plus y minus b squared equals square root equals the radius squared. So that means we need to find out the radius here. So we will need to find the distance between the 2 points. So to do that, I'm just going to use my Pythagoras. Yeah. So I could either draw it out on the triangle on the circle, or I'm just going to use the Pythagoras just in my head. I'll just do it all in my head. So I'll do x2 minus x1 squared plus y2 minus y1 squared. So I'm just doing Pythagoras on the 2 points. That equals square root. So distance between x's is 3. So the mine's just giving me the distance here. 3 squared plus distance between the y's is 6. 2 minus 2 is 8. So 8 squared. That equals 9, 6 is 73. So square root 73. So my radius is square root 73, which is my r. So the equation of the circle is, so this is question A, x minus 4 squared plus y minus 6 squared equals radius squared. So that would be just 73 squared. So square is 73 squared, which is just 73. Cool. Okay, so part B says find the equation of the tangent. Find the equation of the tangent of the circle at P. So it's just a line drawn here. Boom. The tangent that crosses the thing line P. That goes through the coordinates P. So to find the tangent, we know it's perpendicular to the radius. So what we have to do here is find the gradient. If we find the gradient of the radius, we could do the perpendicular and find the gradient of the tangent. So again, y2 minus y1 over x2 minus x1. That equals, so I'm just going to use my two coordinates, 4, 6, 1 and minus 2, yeah? 6 minus 2 over 4 minus 1. That equals 6 minus 2, 4, 8 over 3. So that means the gradient for my tangent is minus 3 over 8. So now to work out the equation of the tangent, I'm just going to pull it into y equals mx plus c. And then substitute the point P that lies on the line. So that was 1 and minus 2. So x is 1 and y is minus, so is minus 2 equals minus 3 over 8 times 1 plus c. Rearrange that. Just take that over to our side. C equals C 1 over minus 2 C And let me just quickly do this. And minus 2 plus 3. So we equal minus 13 over 8. Okay, so the equation of my line becomes y equals minus 3 over 8x minus 13 over 8. Is there any, you didn't ask for any form, so we can just leave it at that. Or we can multiply everything by 8 and then rearrange if you need to. But it's fine like that. Cool. Next up, we have the point AB. The point AB with coordinates minus blah, 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 lies on the circle. We find the equation of the perpendicular bisector. So this one, again, we have a circle. We have 2 points AB, and that's their coordinates. Find the perpendicular. So here, it's going to cut, the perpendicular bisector is going to cut through the middle of the line. So since it cuts through the middle, the first one we need to find is the midpoint. Yeah, because the perpendicular bisector. So the midpoint is add up. So it'd be x1 add x2 divided by 2, and then y1 add y2 divided by 2. So minus 1 plus 7 divided by 2, and minus 9 plus minus 5 divided by 2. And that equals 3 and minus 7. So we've got our midpoint here, m, here, which is 3 minus 7. Let me just write m here. Okay, so now what we're going to do is work out the gradient of this line segment, and because the perpendicular bisector, we could find the gradient of the line going downwards, cutting it. So gradient y2 minus y1 over x2 minus x1 here. So minus 5 minus minus 9 over 7 minus minus 1, which equals a half. 4 over 8, which equals a half. So I know the gradient to the perpendicular bisector is going to be minus 2. Yeah, that's the gradient for the chord. The perpendicular bisector is going to be minus 2. So this is the info we have now. Now we just plug it in to our y equals mx plus c. So y equals minus 2 times y, and we're going to use the coordinates here, m, as it passes through m. We know that it cuts through m. So xy minus 7 equals minus 2 times 3 plus c. Rearrange that. C equals minus 6 minus equals minus 1. So that'll be minus 6. Rearrange up. Minus 7 plus 6 equals minus 1. Therefore, the equation of my line is y equals minus 2x minus 1. Okay, so that's the perpendicular bisector. Next one is show that the perpendicular bisector of AB passes through the center of the circle. So scrolling up the center of my circle. So that's question A. I'll do B on the side here. The center of my circle, so center equals x is 1 and y is minus 3. I just got that from the equation of the circle, yeah? So if I substitute x equals 1 into here, I should get minus 3. So y, because that means it's cutting through the center of the circle, y equals minus 2 times 1 minus 1, that equals minus 2 minus 1, that equals minus 3, and y equals minus 3. Therefore, it cuts through the center of the circle.